Hey everyone, and welcome back. Today we're going to go tackle the fifth problem on NeetCode's 150 top k frequent sorts. So given an integer array numbers and an integer k, return the k most frequent elements within the array. Your test cases are generated such that the answer is always unique. You may return the output in any order. Awesome. So we don't have to sort if numbers are out of order. That's perfectly fine. It's completely handled in the test cases given. Let's take a look at the first example given. We're given a list of numbers consisting of six numbers, 1, 2, 2, 3, 3, 3, and we're given k, which equals 2. So we want the top k frequent most elements, so we want to be able to return a list of 2. And we're returning 2 and 3 because 3 occurs 3 times, 2 occurs 2 times, and 1 occurs once. So the top k, or the top most, or the most frequent element is 3, and the second most frequent element is 2, so we return 2 and 3. That makes sense. Then we're given, in example 2, we're given a list of numbers 7 and 7, and k equals 1. Given that there's only one number here, we would return 7, as that is the most frequent one and the only one that persists. Let's pay attention to a couple of the constraints here. We know that our list will contain at least 1 and a really big number, and go up to a really big number. And we know that the numbers that we're working with persist in the negatives as well as the positives. Okay, so we need to account for that. We need to deal with negatives. Let's see here. K will at least be 1, and 1 will always be less than the number of distinct elements in numbers. Okay, so at most, okay, so K will be less than the number of distinct elements in numbers. Okay, so like we wouldn't have k equals 2 here because there's only 2 numbers here, so we don't have to worry about growing our list and ensuring that our list is the exact same size as k, or at minimum the size of k, because we can always expect k to be less than all the distinct letters here, or distinct numbers here. All right, that makes sense. Let's go ahead and jot down some of our ideas here. So let's talk about cases, right? So we're given a very basic case here, which is this, and then we need to return. We end up returning 2, 3, and here we're given them 7, 7, and we are returning 7, 7. So the constraints are nums will never be empty, k will always less than or equal to distinct nums. Numbers can be negative and positive. We also know that numbers are bounded between negative 1,000 to 1,000. So that's really cool to note. I guess what other use cases? So no empty. So where nums was this, k equals 0, not considered. That's good to know. What other use cases are there? Oh yeah, so if like nums is 1, k cannot equal 2, equals 2. This is also not considered. And other use cases are like -1, -1, 0, 1, 1, k equals 2. We would then return a list of -1 and 1. Okay, so what do we know about this problem? What are the things that we have to do? I guess let's talk about some of the core requirements here. We need to keep count of characters plus their frequency, right? We need to keep track of the highest frequency up to n, or up to k. We need to return, we need to keep count of characters and their frequency. We need to keep track of the highest frequency up to k, and we need to return a list of size k. Okay, so considering that we need to keep count of characters and their frequency, what would we, that's, oh, apologies about that, it's my dog. The first requirement tells me we need a dictionary. We need to keep track of the highest frequency up to k. This can be done through sorting, and we need to return a list of k. Yeah. A part of sorting. Okay. So, with that being said, we have a dictionary sorting. So I guess the first one is dictionary plus sorting, right? Essentially initialize our dictionary. Initialize. Okay, I'm totally butchering how to spell it. There you go. I still think that's wrong. I think that's how you spell it. I could be wrong. So initialize dictionary to keep count of nums plus their frequency to sort the list of frequencies. 3, return of highest frequencies. Right. Frequencies up to n. Okay. What does this mean for us? So time. We need to initialize our dictionary. That's like what? To keep count of numbers and their frequency, that would be like O of n, because we need to go look at every number in our list, right? Sort the list of frequencies. So we need to be able to sort the list of frequencies. So that would be, so sorting the list of frequencies. What does that look like? So sort the list of frequencies. For sorting the list of frequencies, sorting is usually like what? N log n. So we're getting the list of frequencies. At worst, it's n. Yeah, because what if there's only one frequency for each? And log n, and return the list of highest frequencies up to n, which is just n. So that ends up getting reduced to 2n, which is reduced to n. But there's already n here, so n times. So that's n log n. And space is all of n. So initialize the dictionary to keep count of numbers. Sort the list of frequencies. So I think our biggest bottleneck is here. That's the n log n component, right? So the dictionary is fine. Dictionary is fine, O of n. We do have to view all of the, we do have to at least scan our entire list to know how many frequencies are in place. But the biggest bottleneck is sorting the list of frequencies. Is there another way to handle that? Is there another way to handle that? Well, we know that the frequency of characters is fixed to the size of n. So we could reduce our frequency, like the amount of frequencies we're looking at, to just the size of the list. So we could reduce this like O of n, and then this would always be O of n. So as long as we know the size of the frequencies, we can keep track, or we could use something like bucket sort to sort, or not bucket sort. Yeah, but we'll bucket sort. We can essentially we can set a finite list of frequencies and then bucket all the items into that frequency count. So we would still initialize our dictionary to keep count of numbers plus their frequency. That's still all of n, so that's pretty good. 2, instead of having to sort the list of frequencies, we can bucket our frequencies up to all of n. And then 3, return a list of highest frequencies up to n. All right, and this should get us to a time complexity of O of n plus n, which just reduces to n, and space would be O. So we're doing the dictionary here, that's O of n. Bucket our frequencies, which is up to O of n. So that would be O of n. And we'll call this dictionary plus bucket sort. Awesome. Because we have to scan our entire list, or all items within our list at least once, I can't see any other way of us reducing our time to O of n. And since we need to keep track of the amount of frequencies, I can't see us reducing space either, at least to maintain this. So I'm inclined to think that this is the most optimal solution. Let's go ahead and implement it. So initialize the dictionary to keep numbers and their frequencies. Frequencies equals dictionary. Okay, yeah. We could use Python's built-in counter. So from collections import counter, because we know this is a common operation. So frequencies would equal counter, and we would pass in our numbers here. So this should essentially do number 1 for us, bucket our frequencies up to n. So initialize dictionary numbers by our frequency, and we would have frequency equals a list of list. So we could use list comprehension here. So frequency equals for underscore in range length of nums plus 1. So this should get us a 2D list of frequencies. So what I'm expecting here is if the length of numbers is 6, oh, this would be 7. Oh yeah, the reason that we're adding 1 is so that we can capture frequencies. So like if the count is 3, then we would just put 3 in there instead of having to subtract every single time. So yeah, that makes sense. Numbers of frequencies, we have our frequency there, our frequency 2D list. Yeah, and then now we need to iterate through this. So for num, comma, frequency in numbers by frequency dot items, right? So we have that. Now we know what our frequency is. Yeah, so what we would do here is number dot frequency. We go into our frequency dictionary and then into our frequency here equals frequency dot get. If there's nothing there, let me double check the get function. Let's not get Python. Python list. So our frequency is here. Frequency. No, we don't need to do that. I'm thinking of the wrong thing. So we have for number frequency and number by frequency dot items. Frequency at frequency dot append. Yeah, we would just do a dot append because it's a list of a list. I was trying to think, I think I was getting confused with how a dictionary works. So frequency at frequency dot append, we would append our current number there. And simply put, yep. And then we would need to create our output list. Output equals list. All right, so we created our output list here. Here we mapped out our frequency. Basically for number frequency. Okay, so output equals list. For numbers in, we have to go in reverse order though. So we could do that using arrange. So for index and range, frequency, length at frequency, so plus, no, length of frequency. So it's start, stop, skip. So we would start at the length of our frequency, which is 6, minus 1, because we need to start at 5. And then we're skipping by minus 1, or we're stopping at 0, but we're going in reverse order here. This should work. So this should allow us to go backwards. Okay, so for index in range length of frequency plus minus 1, 0, 1. Numbers equals index equals frequency at index. We need to append this to our output while the length of output is less than k, and sub x equals 0, and and sub index is less than, and our sub index is less, well, I'll put less than k, and our sub index is less than the length of numbers. We would then do output dot append numbers at sub index. Sub index plus equals 1. So we have for index and range length frequency. We're going through it in reverse. We're doing numbers equals our frequency at index. Okay, so we're getting our numbers sub index equals 0. Our sub index equals 0, while the length of our output list here is less than k. And simply put, we would return our output. So let's make sure we have this down. So we initialize our dictionary and keep count of numbers and their frequency. That's line 41. Then we bucket our frequencies up to O of n. We created a bucket list here. One sec, create a bucket list here for num and frequency and numbers by frequency and dot items. Yeah, so we're going through this. We're doing our frequency at the frequency count, and we append our num. Okay, so that allows us to bucket our frequencies up to how many numbers there are in the list. Next, we create an output list, and we return list of high up to frequencies up to n. So output equals list for index and range of our frequencies, which should be up to n. We're going in reverse order to get the highest amount. So numbers equals frequency at index. So our list of numbers will be our frequency at index. Our sub-index is 0, while the length of our output is, so while our output is still less than k, and our sub-index one sec, my mic just died, but I'll keep going. And so while the length of output is less than k and our sub-index is less than the length of our numbers array, then we know to keep appending our numbers at the sub-index. So we're basically iterating through this the sublist, and then we keep adding on to it and appending it. So let's go ahead and run this. Sweet. Okay, let's go ahead and submit it. Awesome. All right, I know that one was a little bit longer, but there was quite a lot of things to consider, and the logic for 3 I don't think was as intuitive as it could have been. I think that there's a better way to optimize for it, but this will do. I think this hit our solution.